Holidays, and we're going to start right into the exercises assigned for this week. The first question is about mainly definitions, and we could see that we're going to define weak and strong acids and their conjugate strength, and we're going to look at that. So, which of the following statements are correct? The first statement: based on Bronsted, an acid is a species likely to donate a proton. You all know that, right? So Bronsted acid donates a proton. And that's great. Next one. A strong acid has a weak conjugate base. And actually that's usually not a bad statement. Strong acids give weak bases. But they give such weak bases, these bases become effectively unreactive, and we call them indifferent bases. Okay, so look at this chart. Strong acids have pKa's well below 0. We usually don't put them on the chart. We put all strong acids such that they exist as H3O plus on the 0 scale with water as our base. But still, any strong acid which has a pKa usually below 0, which we don't look at its pKa, always go in a one-way direction. So the base actually has no strength at all. Okay, and then number C. So this actually is incorrect. So B, we say they don't give us weak base. They actually give us what is called a spectator ion. Okay. So we'll keep it that way, at least for the sake of this course. A strong acid has a strong conjugate base. Definitely not. Very, very, very weak one. So that's clearly incorrect. A weak base has a weak conjugate acid. All right, so we're on this here. Now go back to this corner. Weak base. Weak base gives us a weak conjugate acid, and that is indeed the case. So weak gives weak. Clear? And our next one. A weak base has a conjugate acid with no strength. So again, I'm on this scale. A weak base has a conjugate acid that does have a strength. Why? Because this conjugate acid can go backwards and give me, it's a reversible reaction, so it's back and forth. So weak base has an acid with no strength? No, it does have an acid with some strength, and therefore we have our solution is simply A, which is correct, and D, weak renders weak, which is correct. So A and D. Okay. Next question. This is too easy to even put as a question. What is the pH definition? And you all already know that the definition of pH is minus log of H3O plus, and it's a matter of finding the answer in your solution, which is going to be B. What is the definition of pKa? That's number 4. And that also, you know, is a pretty basic. pKa is from the equation. We take an acid, HA, okay, HA reacting with water. So whenever we're talking about Ka, Kb, it's always a reaction with water. And everything we discussed in class thus far is something reacting with water. Okay, we did not discuss anything other than that. And so when an acid reacts with water, it gives me H3O plus. So a Ka is products divided by reactants. So in this case, what would your Ka be? It would be H3O plus at equilibrium times A minus at equilibrium divided by HA at equilibrium. Now, if I was I don't include the water because it's a Ka. If it was a K reaction, we would include the water. And then when we convert it to Ka, K reaction times water concentration would give you the Ka value. Of course, don't forget that the water concentration is actually 55 molar and it's not 1 molar in a solution, in an aqueous solution. All right, so what do we have? We have, this is my definition right there, and it's a matter of finding it, and you find it, and it's, the answer is B right there. Now watch out, because in MCQ questions, it's very easy actually to make a mistake and put the wrong thing. And here they just put the little e's there for meaning the concentration at equilibrium. We don't always put it in the expression, we just keep it like this. We don't always put an e, so watch out for that. The pKa of an acid-base couple is defined as, again, pKa or P of something is always the minus log of that something. So pKa would be the minus log of Ka, and the answer is going to be found as D, and there's your answer, D, okay? These are fairly basic. You don't want to waste time on them. Number 7. Now watch out for the order that I'm doing this in. So we're on number 7 now, okay? Given the following, we have different pKa's of different acids, okay? And acid-base conjugates, that's what they gave us the pKa for. Okay, and we're going to get right into the questions. Ammonia is a weak acid. Now guys, as I said, anything that has 2 pairs of electrons, like an amine or an ammonia, typically these guys are considered more of bases. And if I'm given the pKa of ammonium-ammonia couple, the acid of this couple is actually the ammonium, and you all already know that for sure. So actually, this is incorrect. This is not a weak acid. It's actually a weak base. Okay, so that is incorrect. With equal concentrations in water, acetic acid dissociates more than ammonium. And you guys have to watch out for this. Who dissociates more? Whoever dissociates more is the one that is more acidic. And who is more acidic? The one that has a lower pKa value. So the lower the pKa, the more acidic. And the more acidic, it dissociates more. So with equal concentrations in water, acetic acid dissociates more than ammonium. So where's the acetic acid? The pKa, that's acetic acid right here. pKa is 4.8. And the ammonium has a pKa of 9.2. So who's more acidic? The lower pKa. So acetic acid is more acidic. And therefore, will it dissociate it more? Yes, it will. So this is actually correct. Chloroacetic acid, number C, is the strongest acid among the above species. Well, the strongest acid has the what? The strong acid, the strongest, will have the lowest pKa. And indeed, if we look at the chloroacetic acid, it has the lowest pKa. So is it the strongest acid? Yes, it is. The chloroacetic acid anion, or acetate, is the strongest base among the above species. Now, you guys all should know. Let me just erase everything here. if I have the strongest acid, and we decided that the strongest acid is this chloroacetic acid because it has the lowest pKa, the strongest acid will give us the weakest conjugate base. Okay, so it will not give me the strongest base. Okay, it will actually give me the weakest base. Okay. All right, so that's incorrect. And finally, the acetate, the anion of the acetic acid, is the weakest base among the above species. The weakest base will be the one of the strongest acid. So actually, this is incorrect because the weakest base will be for the chloroacetic acid. And which gives us an incorrect answer, and therefore my only answer would be B and C, which are correct. Now, in such questions, do you really need a pKa scale and a gamma rule? You actually don't, but sometimes it's easy if you do put everything on a pKa scale. So if I had, for example, here, put the ammonia, here's my pKa scale going upwards, and I put my highest pKa right on top, so 9.2 was for the ammonium. I put my acid on this side, and then the 4.8 right below it would be for the acid, acetic acid, and 2.9 would be for the chloroacetic acid. And put whatever base, remove a proton from each, put the base on the other side. Okay. Once you assemble your pKa scale, then everything is already intact for you, and you can automatically say, well, the strongest acid is right there, so this would be the strongest acid, all of them out of the weak, right? These are all weak acids, and so therefore this guy would be your weakest base. Okay, automatically, and then you would answer everything else in the same way. And so here, this ammonium would be your strongest base. Okay. Of course, if you are actually doing reactions, this becomes important to do. It's not, like I said, it's not as important here, but sometimes putting it on a pKa scale can help you answer the questions of strongest or weakest. Okay, and you still get the same answer in the same way.